Y'all, so we're going to talk about non-parametric tests. So today is a sign test for medians. Okay, so let's say you have this data, you organize it, you find the descriptive statistics, so like the mean, maybe the median, the standard deviation, right? And then you create a graphical display. So maybe you create a histogram and you're like, oh, that's skewed. If you cannot have a normal curve, instead of the histogram, you would make the, what would I make? Louder. Box and whisker, right? So I would look at the box and whisker because it's not a normal curve, right? So then I would look at the median instead of the mean, because a mean can be pulled one direction or the other if you've got outliers, whereas the median is always the middle, right? So when do we use parametric tests? Well, that's when we require the shape conditions. So usually, what was one of our conditions? We would look at the curve and it had to be a normal distribution, yes. Good. We wanted that normal bell curve, right? So if that doesn't work, that's when we apply these non-parametric tests, because it does not require right. So probability, when I reviewed your pre-response for the exam, probability was something you said, you know, more time, like going over that more. So I appreciate that feedback. Thank you. Okay. So probability review. Suppose I flip a coin 12 times. So what are my options? What are my outcomes going to be if I'm flipping the coin? Heads or tails, okay? So I'm either going to get heads or tails. What are the possibilities for the number of times that I could flip a heads? So I want you to think about, I'm flipping a coin 12 times. What are my possible number of times that I could flip a heads? I could flip it 12 times. I could flip it 8. So it's going to be any number between what and what? 1 and 12? 0 and 12, right? So this is called a what type of probability when you have two outcomes? Binomial. So remember, this is called a binomial probability, okay? So what would n be? What would my sample size be? 12. What would be the probability for each individual one of flipping a heads? What did you say? I'm sorry? 0.5, 1/2, yeah. So P, which is my probability of success, is going to be 0.5, right? Each of my flips are independent, so I'm either going to flip a heads or a tails. 1 out of 2 will be heads, right? Okay, so 0.5. So do you remember how to figure that out? We said this is going to be, number of heads will be any number between 0 and 12, right? 0 and 12. So the probability that I flip no heads would be x equals 0. Okay. I know it's been a minute since we did this, so I'm going to help you, all right? So the probability that we flip no heads. No heads. That's the binomial PDF or CDF. Am I finding one, or am I finding the cumulative where I add all of them up to that one? That's what CDF means, cumulative. I'm adding all of them. So as I go, probability of x equals 1, that would add 0 plus 1. Is that what I'm wanting? Now I want to find the actual probability of getting no heads, the probability of getting 1 head, the probability of getting 2 heads, right? So I'm going to help you with this first one. I'm not going to make you write it every time, but for me personally, when I write something, it just helps me remember, okay? So to get this, we go second vars, and then we choose binomial PDF. So everybody do that with me. So second vars, binomial PDF, which is actually way down there at option A. And then you'll see it says number of trials. So how many trials do I have? 12. It says what's the probability of P? So that's going to be 0.5. And then X. So that's why I wrote it this way. I'm looking for no heads. So for this one, my X is going to be 0. That's going to change for each of these, okay? And then I'm going to paste it and hit enter. And you'll see it says 2.44140625 e to the negative 4. That's scientific notation. So what do I have to do? Move the decimal to the left 4 times. So this probability is actually 0.000244. Good. So I'm going to do that. All right, so 0 heads, 1 heads, we're going to do this, but I'm going to split you all up so that this doesn't take as long, okay? So I want you 3 right here. If you'll find 1 and 2 for me, okay? There. If y'all will find 3 and 4, the 4 of you, that way you can check one another. The back row of 2, if you'll find 5 and 6, that row of 3 right there. If y'all will find 7 and 8, that row right there, you'll find 9 and 10, and this row right here, if y'all will find 11 and 12 for me, okay? And then we'll come back together and write them all down. So leave yourself some room. I did it like this to leave myself some space. So beside this one, I put x equals 4, x equals 5. From this group, will one of you tell me what 1 was? What'd you get? 292. Okay, thank you. Somebody else from that group, will you give me 2? That. Okay, so everybody that was in the other groups, make sure you record those 2 probabilities. The back 3. Yeah. I love without me even saying it. Both of you gave a different answer. All right. Let's stop here for just a second. Do these probabilities make sense? What should probabilities always be between? 0 and 1. So this makes sense, right? Good. Okay. And do you think it's likely to get no heads? Very likely, is it? Do you think it's more likely to get like half heads, half tails? So do we see as we keep going up, this probability is getting a little bit bigger each time? So for those that did my 11 and 12, do you think those probabilities are going to be high or kind of lower? Lower. Okay. So back there, 5. 9, 3, 4. I agree. Okay? Five, 6. I agree. All right, 7. Next row. 1, 9, 3, 4. Yep. Okay. Somebody from that row. 8. 1, 2, 1. I put 1, 2, 0, 8. That's fine. I think I was just kind of being consistent using 4 after the decimal, but 1, 2, 1 is fine. That's fine. All right. Next row. 9. Okay. 10. 0.016. I left out the 0, didn't I? Try again. 0, 1, 6, 1. Thank you. And last row. 11. 0. Okay. Somebody else from that row? 0.0000244. Okay. Did you like that? Like splitting it up so you didn't have to do them all? Yeah. Okay, good. All right. So do you notice anything now that we have all of these probabilities? Symmetrical, there's a pattern. You notice that the probability of no heads is the same as the probability of 12 heads, right? Or 1, 11, right? Okay, I think that's interesting. All right, so then this is our graphical display. We want to keep reviewing this with you because it's something you're going to be expected to do, right? So you organize the data, find the descriptive statistics so you can start to get an idea. So for this, we found all of our probabilities to start to form an idea, right? So I can get no heads, 1 heads, 2 heads, all the way up to 12. So that's the number of heads flipped. What is this over here on the side then? I thought I had that typed. I do. I must have slid it over too far. Okay, so that's important that we always have labels on our axes. So that's why it's typed on your paper, okay? So what might be in a title for this graph? Heads? Yeah. I put probability of flipping heads. You don't have to. You could put outcome of flipping heads. Yeah. Or tossing a coin, right? You could say tossing a coin. That would be a title. Just as long as you have a title. That's important, right? So I could put tossing a coin, outcome of tossing a coin, outcome of flipping a heads, any of those work, okay? So let me ask you this. When we create this graphical display, is it going to be a histogram where the bars are touching, or is it going to be a bar graph? Because typically for a histogram, which is what she was starting to say, and I get it, if you look at my paper, you'll see something. Normally with a histogram, it means it can be any value between those, right? So it's like ages from 62 to 65, 65 to 68, like that kind of thing, right? Whereas with this, can I flip a coin and get 0.278 heads or 1.67 heads? Now I'm getting those actual values, right? So is it going to be a bar graph or a histogram? Going to be a bar graph actually. And if you look at my paper, I had to go back and do it again because it actually can't be a histogram, okay? So it's not a histogram because we're not getting those values in between. So I'm just going to use this feature because it's kind of nice. What was the probability of getting 0 heads? 0.00024, so it's like right there. And then the probability of getting 1, 0.0029. So these are really tiny, right? Because that's 1/10 up there, so I'm not going to get that. All right, 2 was 0.016, so a little bit higher. 3 was 0.05, so that's going to be about halfway to here, right? So finally, I'm going about halfway between these. Oops. Okay, 4 had a probability of 0.12, so I'm actually going to go above 0.1 a little ways. Was 0.19, so that's almost 0.2, so I'm going to go to here, really close to that line. 6 was 0.225, so I'm going to go above 0.22, is above 0.2. And then 7 was 0.194. So when he said symmetric, yes. So these lines will be exactly like those. My line just turned out crooked. All right. That drawn in. It says, what would be the probability that I would flip at least 10 heads? At least. What does that mean? 10 or more. Yes. So what's the probability that I would flip greater than or equal to 10? Now, since I've already found each of these individual ones, what can I do? So I can add the probability that x equals 10 plus the probability that x equals 11 plus the probability that x equals 12. So that's going to be 0.0161 plus 0.00292 plus 0.000244. What do you get? What do you get? 0, 1, 9. Yeah, 192. 64. Thank you. I'll just stop there. Okay. What if you hadn't found all those individual ones? Do you remember how to do that in your calculator? Good. 1 minus binomial CDF. But remember, your calculator includes whatever number, right? So if I want 10 or more, I need to do 1 minus 10 or 9. If this is my graph, which is how I think it through, I want this plus all of these, right? So CDF includes it. So if I include it, it's only going to give me 11 and 12, right? So I actually need to do 9 down, right? So if I do the binomial CDF, number of trials would be 12, P is 0.5, and then I would be doing below 9, right, to subtract that out. Let's look at that and see what happens. 1 minus second vars, binomial CDF, trials is 12, P is 0.5, X value is 9, at 0.01928, which is pretty close, right? So you said 6, so I could round that to a 3, couldn't I? I say that because if you haven't done all of those values, you didn't have to find every individual one. That would save you some time, right? All right, go ahead and answer question 2 and try to answer question 3, and then we'll go over it together, okay? So the probability that I would flip at most 2 heads means 2 or less. So that's going to be the probability that x is less than or equal to 2, including 2, right? So to find that, I could do the probability of flipping no heads plus the probability of flipping 1 head plus the probability of flipping 2 heads, because at most 2, okay? And when you add those, did you get 0.0193? Does that make sense based on my distribution? Yes, I'm adding those probabilities versus a while ago I was adding these, but it's symmetric, right? There's a reason why we're talking about it. Don't worry, just trust me for a second. Because this is probability of 10 or 11 or 12. And if it's or, we add. If it's and, we multiply unless it's given in a table where it says like senior Bassett. These students go to seniors and go to Bassett. That's one number, right? We're not going to multiply seniors and Magna Vista, seniors and Martinsville, juniors, same thing, right? So I could split all of Gov School here into those classifications. So if I said, what's the probability a student is a senior and goes to Martinsville, I would just find that and divide it by my total. I wouldn't actually multiply, right? All other problems we typically multiplied, right? Okay, so what would be the probability that I flip at least 10 heads or at most 2 heads? What am I going to do? Those together, yes, 0.0193 plus 0.0193, and then I get 0.0386, right? Any questions? So distribution is this. Normal. These probabilities have a normal distribution, okay? So if we look at this, we have annual income in thousands of dollars, and it was recorded for a random sample of 15 families in a certain town. The results were as follows. So the annual income in thousands of dollars, so this would be 75,000, 10,000, 92,000. Everybody understand that? Okay. We would like to know where the true center of this data would fall for the population of this town. So if that's my raw data, the first thing I might do is put it from least to greatest so I can look at it, right? Or a way to do that and get a graphical display all at the same time, putting it least to greatest and get myself a graphical display, is by creating a dot plot. Y'all remember how to do that? So you just create your number line. You have to use even increments. So I can go by 20, I could go by 5s, 10s, whatever, but you have to use even increments, okay? And then I'm going to actually put these data values. So 75, this would be 70, so 75 would be halfway, so I'm going to put an X right there. So I got my 75, then 10 would be halfway right here, so that would be 10, right? So it's a frequency distribution because I stack them above one another when they're in order, right? So this will be 10, so then 92, here would be 90, it's going to be right beside it. Then 49, if this is 50, it's going to be about right there. 58 would be really close to 60, so about right there. 25, if this is 30, so it would be halfway between them. You see how to do this? So everybody keep going. God bless you. All right, so I always like to double check. It said we had a random sample of 15. I like to go in and make sure I actually graphed 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Would you say this is a normal distribution or it's skewed? Would you say there appears to be an outlier? Yes. 200,000, right? So that outlier is going to do what to my mean? It's going to shift that mean. It's going to pull it up here probably somewhere, right? So just for your information, if you were to put this data in L1 and then do one variable statistic, so you go to stat, calculate one var stats, it would have told you that X bar is actually 62.3, which would be here, right? Do you think the mean's actually that high? No. So what would be a better representation? The median, okay? So I'm actually going to put that in here. I'm going to put the mean, which is X bar, would be here. And I don't think that's a good representation. So instead, I'm going to do the mean. The median. Do you remember how to find the median? It's the number in the middle, right? And have I organized my data values? Right? 200 would be with the 10, and this one, and this one. You see what I'm saying? Now, if that doesn't work for you to like imagine cross them out, you could absolutely go in order up here. So it'd be 10, 10. So I have that one and that one. And the next would be what? Where is that? There it is. 20. And then 34, right? Wait, 25. That's right. 25. And then 34. And 3. Or you could put this in your list, do one variable stats, and scroll down, and it'll tell you your median, which is what I'm assuming most of you would do, right? One var stats, okay? You go to stats, calculate one variable statistics. Or you can put them in order, and then just find the middle by crossing them out, okay? So to save us some time, I am going to tell you the median, which we represent with an M, is 49. We had two 49s, didn't we? Wasn't this my 49s? So those two right there are my median. So M equals 49. The median, the middle of the data. Okay? So then it says, what is the shape? We already said that. What is the shape? Skewed. And is it right skewed or left skewed? Yeah, if we were drawing this, that tail would be pulling to the right. Can we confirm that mathematically? The answer is yes, because the mean is greater than the median. That confirms that it is right skewed, because your mean's being pulled that way towards the right, okay? That's a way nicely to verify it using numbers. If the mean is greater or to the right of the median, it's right skewed, okay? All right, then it says, so which statistic would be the best measure of center? Here, this is my answer to the first one, so this is going to be my answer to the second one. What do you think? The median, yes. The median doesn't get affected, right? So the median, and then why? It's skewed, yes. So since the distribution is skewed, it's a better representation. You know, it doesn't get pulled one way or the other if you have outliers, okay? So the town reports that the median income in the town is $40,000. Just blanked on how to say that word. economist, there we go. An economist is interested in determining, God bless you, whether the population median income has increased since the town's last report. So the report is it's $40,000. We found with this data that it has a median of what? Right? So, is it statistically significant? That's the reason why we do stats, right? We don't just look at numbers and go, oh yeah, we actually run a test, okay? So the way that you do this is you're gonna actually test the median, okay? So I'm gonna set up a null and an alternate, and I'm looking at the median. It says determine whether the population median income has increased since the town's report. So I want to see if the median is greater than, what was the report? 40,000. So because though my data was given in terms of thousands, I'm going to write M is greater than 40 because of the way my data is given. Everybody see that? Instead of putting 40,000 because these are given in thousands of dollars, I'm just going to put 40, okay? We want it to be consistent. So then this would be median is less than or equal to $40,000. Okay, check the conditions. There's only one condition for this type of test, and it's random. So is this random? Yes, it was stated, right, or given. Okay, determine the p-value. All right. So what you have to do is you have to compare all of the data values to the claim, okay? So if I look at these data values up here, the claim is that the median is 40, all right? So what I went and did on my paper, let me erase these, because that can be confusing, is up here, compared every one of these numbers to the claim. So the claim is the median is $40,000, right? Is $75,000 above that number, below that number, or equal to that number? Above. So I'm going to put a plus here. Is 10 above, below, or equal? Below, so I'm going to put a negative. It's below it. How about 92? Above 49? Above 58? Above 25? Below 96? Above 40? Equal to. So what you put, it's not above it, positive, it's not below it, negative. Instead, you just put 0 because it's exactly equal to it. It's 0. There's no difference. Okay? 90? Above 87? Above 10, below 49, above 20, below 200, above, and 34, below, okay? So I've compared every single data value to the claim, which is that the median is $40,000, okay? So what we're going to do down here is we're going to write plus, minus, 0. And now you just count how many plus signs you have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which tells me there's 9 data values that were above that claimed median. Any minuses do you see? 5. Any zeros? 1. And what was 0? It was whatever that claim was, and that value is equal to it, okay? So that's how you figure it out, all right? So these 3 numbers should always add up to your sample size. 9 plus 5 is 14, plus 1 is 15. So I got them all, okay? So it should always add up to your sample size. The next thing you do is we're going to ignore this data value then, that's 0. Because it wasn't above the claim, it wasn't below the claim. It was equal to it, okay? So now I'm going to take these two numbers and they give me my new sample size. So n is equal to 14. Okay, so you exclude this when you're finding your p-value. Exclude any of the data values that are equal to the claim. Okay. The next thing you do is you find your x by always using the smaller of the two. So are my positives smaller or my minuses? My pluses or my minuses? My minuses. So x on this one is going to be from the minuses right here, and it's going to be 5. Okay? It doesn't matter if it had been the pluses. Whichever number smaller is what you use. All right? Okay. So now we're going to find the p-value, okay? Because you use the smaller of the two, you don't have to worry about doing 1 minus or whatever for the alternate. You know, usually if it's greater than, we have to do 1 minus, right, to get it. But because you're using the smaller of the two, you always just use it. Now, if it's not equal to, we have to do what to get the p-value? If it's not equal to, it means how many tails are there? 2. So you do have to multiply by 2, okay? So the way that you find the p-value is what we did on this slide. They're always symmetric, which is why you don't have to subtract from 1. They're always symmetric for these probabilities. So when you use the smaller of the two, you don't have to do it, okay? All right. So the way that you find it is binomial CDF, okay? Because you're adding those probabilities. So you're going to go second vars binomial CDF, and because it's a binomial, it means there's 2 possible outcomes, okay? Which means my p is going to be 0.5, just like on the last example we did, okay? All right, so the first thing you put is the number of trials, which is your sample size. So what am I going to put? Yep, that's why I wrote it right here, 14. And then p is always 0.5. So for all these problems, it's always going to be equally likely, okay? So 0.5, which is my p. And then the last one is what I'm looking for. So I told you, you always use the smaller of the two. So I'm going to put, which is my x. Okay? Hit enter, and you should get 0.2119750. Which you would probably round to what? 0.212. So that is my p-value. Do I have to subtract it from 1? No, because you use the smaller of these two, you don't have to subtract from 1 when it's a right tail test, okay? You don't have to do it. Now, if it's not equal to, you do have to multiply by 2, okay? All right, so let's compare that p-value. I don't think I gave you an alpha, so when I don't give it to you, we typically use 0.05. So is that greater than or less than? Greater than. So we would, if it's greater than, do we reject or fail to reject? Fail to reject. So we fail to reject who? The null, which is the claim, right? So we fail to reject the null, which means there is not sufficient evidence at the 0.05 level of significance to conclude what? To conclude that the median is greater than $40,000. It says the town reports that an economist is interested in determining whether the population median income has increased. So has it increased? statistically significant, right? If I looked at this data, it looks like it's increased because my median was 49,000, right? But that's the beautiful thing about running a statistical test is it shows you if it's statistically significant or not, which means if people were to do this 95 times out of 100, they're going to get that the median is not greater than 40,000. Okay? Questions for me? Let me say this one more time because it was the one thing that I kept being like, because we did it all first semester and with every other type of test, okay? If you have greater than here, for all the previous tests, we had to do 1 minus, okay? But for this one, because you always use the smaller number here, and because the binomial distribution is symmetric, we don't have to do 1 minus it. Now, if it's not equal to, you do have to multiply by 2 though, okay? So you would put second bars, your binomial in, you would get a number. If this is not equal to, you have to multiply that number by 2. Okay, everybody? All right, I want you to try this one, okay? And then we'll go over it together. All right, so I'm going to read it to you and then I'm going to let you try it. It says the length of time in minutes needed to perform a certain type of surgery was recorded for 32 operations. The results were as follows. A hospital administrator is interested in determining whether the median time for surgery is less than 170 minutes. Perform a test at the significance level of 0.01, okay? So how am I going to figure out my pluses or minuses to write in here? We compare it to the claim, right? So a hospital administrator is interested in determining whether the median time for surgery is less than 170 minutes. So null, alternate, conditions. Isn't that what we always do? Okay. We're not going to change it with this one. So what's the claim? What's the hospital administrator's claim? Because that's what goes in the alternate. The median, which we represent with an M, is less than 170 minutes. So I'm going to compare all these to what? I'm going to compare it to M equals 170. Yep. And then last thing, and then I'll turn you loose. Conditions? Random. Remember, if it doesn't satisfy it, we still move forward, right? All right, when you go through to compare all of them to 170, I'm not going to put them, but on my paper you would see pluses and minuses, right? So you'll see a minus here because it's below, a plus here, minus, minus, right? Minus, 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 and you would keep doing that, okay? So once you do that, you're going to write plus 0. Okay? And how many data values do I have? 32, right? So I need these numbers to add up to 32. So how many pluses did y'all get? 8. How many minuses? 24. And how many zeros? I got, which makes sense since 8 plus 24 is 32. Okay? So on this example, my sample size is still going to be the number that I use, right? So n equals 8 plus 24, which is 32. My x is always the smaller of the two. So what am I going to use for x on this one? 8. Good. And then I'm going to do second bars, final, CDF. My sample size is 32. P is always 0.5 for these problems, okay? And then I like to write it right here so that I know what I'm plugging in, okay? You do that, you get 0.0035. So y'all got? Okay? If I compare that to alpha, that's my p-value. I'm going to compare that to my alpha, which is 0.01. This is less than. If the p is low, reject. Yep, so reject the null, which means there is or is not. If we reject it, there is. Good. There is sufficient evidence the 0.01 level of significance to conclude, to reread it, to conclude that the median time for surgery is less than 170 minutes, right? It's whatever's in our alternate, and that's what we had. So to conclude that the median for surgery is less than 170. Any questions? No? I think it's pretty straightforward once you see the process, right? I just wanted to reiterate what to compare it to, though, right? You don't actually find the median for the data values. It's whatever your claim is, okay? All right, everybody, go ahead and try example 3 for me. We'll go over it. Okay, so the highest non-irrigated wheat yields in the United States are in the, I don't know, Palouse region? Palouse? Palouse? Okay. Of eastern Washington and northern Idaho. Following are hypothetical yields in bushels for 15 randomly selected areas of farmland. Can you conclude that the median yield differs from 75 per acre? So what would my null and alternate be? My null would be the median is equal to 75 bushels, and my alternate will be not equal to, right? Which means it's going to be a two-tailed test, okay? And then my conditions for this non-parametric test, random. Does this one satisfy it? Yes, it says randomly selected. Yep. So it was given or stated. Okay, so then you compare these data values to the claim, right? So then we have plus, minus, and 0. How many did you get were higher than 75? 10, below, 4, and equal to 1. So we're going to exclude that value. Okay, so instead of using 15, we're going to use n equals 14. The smaller of the two is 4. So we're going to use x equals 4. So then it's second vars PDF, right? Sample size is 14. P is always 0.5 for these, and then 4. And you get 0.0899. No, 898. So is that my p-value? No. So my p-value is actually 2 times that, which is 0.1796. Because it's a two-tailed test, this number is only one of the tails, so I have to multiply by 2, okay? So now I'm going to compare that to alpha, which is 0.01. That is what? That is greater than, so we failed to reject the null. Which means there is not sufficient evidence at the 0.01 level of significance to conclude that the median differs from 75 bushels per acre. Okay? You can work on your problem set.